Now we have question number 35 of this series IIT JAM 2026 PYQ solution. So the question is as we have x1, x2 random sample of size 2 and each is exponential theta distributed and their theta is greater than 0, which is an unknown parameter, and t1 is defined as this, t2 is defined as this. We need to check the statement and there can be more than one statement that can be true. So first is t1 is an unbiased estimator of this parameter. So in order to check whether any statistic is an unbiased estimator or not, we need to verify that for a expectation of t1 whether it is equal to e to the power minus 2 by theta or not. So this is nothing but, as t1 is defined as this, we can write 1 into probability of x1 greater than 0. Then if t1 is 0 plus 0, that is, since x1 is exponential theta, we can simply integrate 2 to infinity e to the power minus 1 by theta x, 1 by theta. In instruction there is given the PDF of exponential theta, that is fx is equal to 1 by theta e to the power minus x by theta, and x is greater than 0. So now here minus theta by theta e to the power minus x by theta, after integrating, then limit is from 0 to infinity, that is e to the power minus 2 by theta. That imply t1 is an unbiased estimator of e to the power minus 2 by theta. So first option is correct. Now we have to check for t2 is an unbiased UMUE of an e to the power minus 2 by theta, and t2 is defined as this. So by definition UMUE is an estimator function of a random sample, that is statistics, which is a function of complete sufficient statistic and unbiased estimator of the parameter, that is this e to the power minus 2 by theta. Then we can say that statistic is an UMVUE of that parameter. So here t2 is defined as this, and which is kind of complex function. So let us do some trick. For example, since we have find from first that t1 is an unbiased estimator of e to the power minus 2 by theta. So by definition of UMVUE, we need to find the unbiased estimator, any function that is an unbiased estimator of parameter e to the power minus 2 by theta and function of complete sufficient statistic. So here random sample is x1 and x2. Joint distribution of this two is 1 by theta square e to the power minus xi by theta. That it is belonging into exponential family. So from exponential family, we can say that t is equal to summation xi is complete sufficient statistic. So where t is I to summation xi. So here t2 is defined as maximum of 0, that is this maximum of 0 x1 plus x2 minus 2 divided by x1 plus x2. That means this is nothing but maximum of 0 comma 1 minus 2 by t, that is it is a function of complete sufficient statistic. So if we prove that t2 is equal to nothing but expectation of t1 given that complete sufficient statistic, since t1 is an complete sufficient statistic, t1 is an unbiased estimator, and if I prove expectation of t1 given t is nothing but t2. So by definition we can say that t2 is an UMVUE. So let us check expectation of t1 given t. Here since t1 is nothing but 1 and 0 for x1 greater than 2. Okay, and t is x1 plus x2. We know x1 by x1 plus x2 take as u, and x1 is exponential theta, x1 plus x2 is gamma 2 comma theta, and x1 and x2 are independent. We can say that this is following beta 1 comma 1, which is nothing but uniform 0 1. Okay, that means we can take x1 by x1 plus x2 some u. Since x1 plus x2 is t, we can take x1 is equal to tu. Now expectation of t1 given t, that means expectation of probability of 1 into probability of x1 greater than 2 given t, or probability of x1 by t greater than 2 by, so or like this 2, or probability of t not, we have taken x1 by t as u, that is this is nothing but probability of u greater than 2 by t, where u is uniform. What is the probability of this? This is nothing but 2 by t to 1, since u is uniform 0 1. This is 1 dx, that is 1 minus 2 by t. Now if we take expectation of t1 given t is equal to, for t less than or equal to 2, let's say for t equal to 2, if we put here t equal to 2, this would be 1 minus 1 is equal to 0. That means it is 0. This is 0. For t greater than 2, this is nothing but 1 minus any value of 1 minus 2 by t, that is this. And we can clearly see this is nothing but maximum of 0 comma 1 minus 2 by t, which is nothing but t2. Hence we can say that t2 is UMVUE of e to the power minus 2 by theta. That means TB is also correct. Now variance of t1 is less than or equal to 2 by theta e to the power minus 4 by theta for all theta greater than 0. Here t1 is defined as this. So variance of t1 is nothing but expectation of, from here we can see that t1 is taking value 1 and 0 only for x1 greater than 2 and otherwise 0. Can we say that t1 is in binomial distribution with probability of success as x1, probability of x1 greater than 2? No. So from here variance of t1 can be said as p and pq, or this is nothing but Bernoulli, na? That is pq. We can take it as pq. That means e to the power minus 2 by theta 1 minus e to the power minus 2 by theta. That means variance is e to the power minus 2 by theta 1 minus e to the power minus 2 by theta. Now we have to check whether e to the power minus 2 by theta 1 minus e to the power minus 2 by theta is less than or equal to 2 by theta e to the power minus 4 by theta for every theta greater than 0. So that means if this is true, we can divide e to the power minus 4 theta both side. We get here e to the power minus 4 by theta, and this will be cancel out from here. So we get this less than or equal to this only 2 by theta. So we can write e to the power minus 2 by theta 1 minus e to the power minus 2 by theta into e to the power 4 by theta less than or equal to 2 by theta. That is 1 minus e to the power minus 2 by theta e to the power 2 by theta less than or equal to 2 by theta. That means e to the power 2 by theta minus 1 less than or equal to 2 by theta. That imply, since we have to check for every theta greater than 0, let us check for theta tends to infinity, for large theta. If it is true for large theta, then we can easily say. So for theta tends to infinity, e to the power 2 by theta can be written as 2 by theta 1 plus 2 by theta plus 2 square by 2 theta square. That means e to the power 2 by theta minus 1 is nothing but almost 2 by theta plus 2 square by 2 theta square. So clearly from here we can say that e to the power 2 by theta is somewhat this, that is this, plus some positive quantity. That imply e to the power 2 by theta minus 1 is greater than 2 by theta. That means C option is correct, wrong. So here C is wrong. Now to check whether x1 x2 is a complete sufficient statistic or not, since we have parameter of dimension 1 only, parameter is of dimension 1, and we have that statistic of dimension 2, and we know in order to be a complete statistic, this can be sufficient. This is actually sufficient. Whole random sample is actually always sufficient. But in order to be complete, the dimension of parameter and statistic should be same. Here the statistic dimension is of 2 and parameter here is only theta, that is 1. So this is wrong. So the correct option is only A and B.